Alright, so for any two events, A and B, you have this. So here's a way that you can figure out the probability of the union happening, or even the intersection. It just depends on what you're actually given, without like trying to figure out a Venn diagram or anything like that. Okay. So here's an example. It says a card is drawn at random from an ordinary pack of 52 playing cards. Find the probability that the card is a heart or a king.
Or kings.
Okay? So, basically, the fact that it's or a heart or a king represents the union. Because what's the what represents A? That you'll get a heart. What does B represent? Probability that you the event of you drawing a king. So to figure out the probability that you'll get a heart or a king represents this union right here. So you need to have the probability that you'll get a heart. What's the probability that you get a heart with a deck of 52 cards? 13 out of 52. See, somebody put some cards right there. Yes, 13 out of 52.
I see like what we know a little more about you.
Plus the probability that you get king. How many kings are in the deck? 4 out of 52. Then you have to subtract the probability of their intersection. The intersection between a heart and a king. How many cards have a heart and a king? 1, that king of hearts. So you subtract that from the probability that you'll have a heart and a king, which is 1 over 52. And once you do the math, you'll figure out the probability that you'll have a heart or a king, the union between A and B, which is 16 out of 52. Does that reduce?
Yeah,
4 over 13. So item will be 7. See how it works? The addition rule? Let's look at another one. You see where that EX is with nothing beside it? You gotta write in this one because that's a lot of symbol drawing. So that's why I didn't put it up there.
I thought you were going. Was it scary? I thought you
There you go. Go ahead and write this one into that example that's in the open space. And that was you have to try to figure it out before I put it. The addition rule said that the probability of the union is the probability of A plus the probability of B minus the probability of their intersection. Okay? And the truth is we have P of A, we have P of B, what we don't have is the intersection, nor the union. But we do know that the union is 2
of the pan.
of the intersection. So what we can do is plug in. We can replace this probability of the union between A and B with a 2
Pan.
probability of the intersection, because that's what it equals right up here, wasn't it? We know the probability of A to be 9/20, probability of B to be 3/10, and we don't know what the intersection is. Okay? Now again, the intersection is going to help us because once we figure it out, we just, plug it in and figure our answer. So,
You can turn the 3/10 into 6/20.
yep, when we add 9/20 and 3/10, that becomes,
15/20.
because you have a common denominator, 20, times the intersection. Sorry, I'm trying to make these look. And this is basically a linear equation. This probability of A intersection B is just a variable. It's just X.
And you can add the pan.
Add the probability of the intersection between A and B.
And then you multiply by 1/3, because it's just nicer that way.
You multiply by 1/3, divide by 3. Then you'll find the probability of your intersection.
I got 1/4.
Because since this was a minus probability of the intersection between A and B, you could have added that over, and then that's how we get 3 of them.
You get 3 pounds.
So 15/20ths divided by 3,
I got 0.25, which is 1/4.
which is 1.
That's not bad.
Alright, so we'll finish off this problem and the rest of the notes along with conditional probability tomorrow. You got 5 problems for your homework that I'm going to post on my big campus. I didn't want to post anything or give you anything we hadn't gotten to a certain point. So now that I know where we are, I'll post it. I'll go make a copy, scan it, and put it up there hopefully soon. And I will see you guys tomorrow.
Yeah.